So after you make a decision and a conclusion, it's possible to run into these things we call errors now. And what happens is you can think of a court case again in the robbery scenario that we've been looking at. If the person that was convicted of the crime really did not commit the crime, then we made an error. Or the other error could be if the person committed the crime but we didn't convict that person, then we also made an error. So what can happen is you can either lock up an innocent person or let a guilty person walk. Those are the two errors that can be made here. And we're going to name those errors type 1 and type 2. And a type 1 error, we're going to assume that we're going to start here. Let's start again with the null and alternative, where the null hypothesis, HO, again, is that mu is equal to a person is innocent. And the alternative, HA, is that the person is not innocent. Or in this case, that means that they are guilty. So if we take these, we can develop what's called a type 1 and a type 2 error. A type 1 error occurs at the probability of what we call alpha. Remember, alpha is our significance level. So if we say our significance level is 5%, for instance, that means we are okay with making a error, the type 1 error, 5% of the time. And in this case, a type 1 error would be, in the court case, is when we reject a true null hypothesis. So in order for a true null to occur, here's what has to happen. For a true null, the person has to be innocent. Then if the person's innocent, what is the error you're going to make there? Well, if they're innocent, you're going to lock them up. So what does that mean? Well, we say that they're guilty. So here's how it starts off. You say guilty, but in reality, they're innocent. So what have you done to say somebody was guilty? Well, you had to reject HO. You had to reject HO, but the error was that HO is actually true. So here is the error that occurred. This is a type 1. And if we say that's 5%, that means 5% of the time we're going to lock up an innocent person. So if you're okay with locking up an innocent person 5% of the time, that's what I mean by the alpha value is arbitrary. If you said at 5%, you're locking up you're locking up an innocent person 5% of the time. You said it at 1, you may say 5% is way too much. So instead of setting it at 5%, you decide to bring it down and set it to 1%, which means you're going to lock up an innocent person 1% of the time. And that's good. We want to lock up innocent people as less as possible. But the problem with that is this. We're going to go to what's called a type 2 error. And a type 2 error is when we fail to reject a false null hypothesis. So that means now we say that we say they're innocent. But this is false. That means you're committing error. So you're saying they're innocent, but that's really false. So in reality, they are guilty. Well, how does this error occur again? You're going to fail to reject. You're going to fail to reject HO. But HO should actually be rejected. But HO is really false. Fail to reject means you're saying the person is innocent, but really they are guilty. That's a type 2 error, and we call that beta. Now, beta is a little bit harder to calculate, and we're not going to worry about it for this course. But the thing you need to know about beta is that it's inversely related to alpha. And what that means is as alpha increases, beta decreases. So as we increase, and I want you to think about in terms of the court case, as you increase the probability of locking up an innocent person, what does that mean? Well, in order to lock up a lot of innocent people, what do you have to do first off? You naturally have to lock up a lot of people to begin with. So if we're locking up a lot of people, what does that also mean? Well, I'm going to lock up a lot of innocent people. I'm also going to lock up a lot of the killers or the robbers that are robbing places like that, the thieves. So I'm going to do a lot of, if I'm locking up a lot of people to begin with. So if I do that, if I lock up a lot of robberies or thieves like that too, what happens then? Well, that decreases the beta, the type 2 error. Likewise, if I say, hey, locking up innocent people too much, or 5% is way too much to lock up innocent people, and I dropped it down to 1%. So I'm going to commit that 1%, that alpha error 1% of the time, or that type 1 error 1% of the time. In order to do that, what has to happen? Well, if I don't want to lock up a lot of people, I have to let a lot of people walk. So if I'm letting a lot of people walk, not only am I letting innocent people walk, I'm also letting thieves and killers and robbers walk too. So what happens there? Well, the type 2 error goes up. So there's this trade-off that happens. If you want to decrease the alpha value, if you want to decrease the amount of innocent people we lock up, we have to increase the amount of people we let walk. And that means you're increasing your type 2 error. Likewise, if we want to decrease the amount of people we let walk, we have to increase the amount of people we lock up. So you lock up more innocent people, which increases your alpha value, right? So keep that in mind as a trade-off there. So we're going to talk about type 1 and type 2 errors and examples now. So in this example, it says, identify the type 1 and type 2 error for each scenario. Give the consequences of each. Which one is more serious? So this is what errors do. Errors present the seriousness problem. And here's how it works. The USDA limit for salmonella contamination for chicken is 20%. A meat inspector reports that the chicken produced by a company exceeds the USDA limit. You perform a hypothesis test to determine whether the meat inspector's claim is true. So let's start here by creating a hypothesis for the situation. We're going to start off by saying HO is mu is equal to 20%. Or if it's 20% or anything really less than 20%, we're going to say that it is safe. And we'll let HA be mu is anything. Well, if it exceeds it, that means it's greater than 20%. And that means that it is not safe. So we're testing these two things right here. Now let's talk about our errors. We have two types of errors that can occur. The type 1 error. In order for a type 1 error to occur, HO has to be true. So the meat has to be safe. But how do we make the error there? Well, you say that it's not safe. So the error would be saying the meat is unsafe. But in actuality, it is safe. Well, if we say the meat is unsafe, in actuality it really is safe, what are the consequences that are going to occur from that? Well, if you say that it's unsafe, what are you going to do? As a manager of that company, what would you do? Well, you would shut down production and you would have a loss of product. You would throw away good product. And shutting down production is also going to make you lose profit because you're throwing away product. So you can't gain profit off of that. So that's a type 1 error. And a type 2 error, well, what's this one? So now, in order for a type 2 error, we have to fail to reject a false no. So it has to be a false no this time. So the meat's really unsafe. That would be the false no. Or the meat is unsafe. That's really what's happening here. But we say it's safe because we failed to reject this false no. So it looks like this. You're saying the meat is safe. Which is actually false. That's false. It's not safe. But really, it is not safe. So what's the consequence here? Well, the consequences here are people are going to eat your bad product. And what can happen when people eat your bad product? Well, we have lawsuits that can occur. And we also have a possibility of death. People taking on salmonella. So out of these two errors, which one is worse? Well, the worst error is going to be anything that involves death. So the worst error is the type 2 error. And if you want like real life examples of this, think about like if you've ever eaten Bluebell ice cream. Bluebell a while back ran into the same type of thing with diphtheria and they did a hypothesis test where they checked to see if their product was safe or not safe to put on shelves. They found out that it was safe in their hypothesis test, but then people started to get sick. And then they realized, hey, we made an error. Well, what kind of error did Bluebell make? Again, it's the same thing here. Mu is that it's safe. HA is that it's not safe. They failed to reject a false null hypothesis. They made a type 2 error by putting their product back on the shelves, and people got sick from it.